So hi, here is another video to show you the light source. Okay, so first of all, let's see. Through the optical fiber, through this optical fiber, once we turn the light, the laser from there, the laser will go through this optical fiber, and the light source will go through this side. So let's see, we can take this out to measure the laser intensity, and this is the detector for the measuring the intensity. So I do this way and measure the intensity in this way, and that is the energy meter for the laser. It is connected to this head. The first thing we'll need to do is to make the better offset. It should be 0.00, right? It's very sensitive. It is better to have the perfect, but it's okay to be 0.01. It's fine. And here's the laser power, and the order is important. The first thing to do is to check if the power is on the right place. So that power is connected to this laser, and this one is connected to when you use the single molecule, this power, right? So as you can see, the bottom, and it goes to over there, right? So now it is connected to here, but they are the same model, so it is same way to make the laser happen. So power on, this one, and a few seconds later, like you start your car, it's the same. Rotate to right side and release it, and the light will come up, the laser. And what those indicate here or here is the knob of this one, but I don't recommend to tweaking it. So the millimeter here indicates these lines. You'll figure it out, but yeah, don't touch it if not necessary. So the laser line, current laser line is 514 or 514.5. So laser comes here, right? The green lasers. It has been adjusted by me, so unless you accidentally touch it, is not necessary to modify it. As you can see, the laser, this is the intensity of laser, 0.18. It should be milliwatt, right? Milliwatt. You see the laser here, right? Because I'm holding the camera by myself, so I don't want to make it move with one hand. So you see it is 0.20. It has been 0.20 like a month ago, maybe a couple months ago. It is still 0.20, so it's very stable. So once it has been so the intensity can be adjusted with this knob. by rotating. Left side is weaker, right side is stronger, but it doesn't really, I would say 0.20 is the best. And this is the light source for this one, and this will be just the same, the power, and make it happen the second, and the intensity knob is here. So the laser will go through to this back port as I explained earlier. So when you stop, it is same way, but in reverse way. You make it off first, right? And then we will need to wait for at least 10 to 15 minutes to make it cool down. So, and then so after we off, after 10 to 15 minutes, after all the fans is turned off, you can just make it off here, the power off. Click the switch. That's pretty much it. And here's the mercury light, and just the light source for the microscope. So the mercury light comes from this the module, and this light is connected to, probably should be here, and so the mercury light comes from here, and then will be reflected to the bottom side, while that microscopic light source comes from the bottom and goes to the bottom to the top this way to make the sample brighter, to see the sample through this microscope. And knob here is when you take it out, as you see that the 100% of the emission light through the microscope lens will go through the top, going there, 100%. When you put this in, the light of the sample will go through you to your eyepiece. So make sure if the light is not too intense to either of your eyes, to protect your eyes and the machine, the scan head. It is also very photosensitive. Okay. Let's see. So how you use it? You rotate it to the dial here, then the light will come up here. See the light, right? And once you put the microscope lens over there, you will see the light from the mercury. Once you make this shutter open and close it, you'll see the light, but it will take a few minutes to make this warm this up, right? And those are the filters, and that means it is open, so every light goes through in and out. And there are different filters over there. If you are curious, you can open it to see what filters are in. So those are filters over there. It's hard to see the filters at the end, but they are how those filters are the implemented. Okay. it's hard to just hold this camera by myself, but this should be fine. Okay, turn this off, detector off. So no more lasers here, so I can put this in, put this back to the. So the thing is, when you put this in, there's a specific direction this is marked, right? This should be matched to the mark over there. Oh my gosh, yeah, right. And it should be injected more deeper. So you see that they match. They are matched well, right? And then make it tight with this, so it is very solid, right? And in case you need to, you want to calibrate the meters of the emission light, there are 4 meters: M1, M6, M5, M4. And I wrote here, M1 is for laser beam, M4 is emission beam, and they are all described in the manual. The manuals are manuals of those that laser scanning microscope is here. You can find the information over there. And so the way you put the microscope, I will show you briefly. I'm not sure how to hold it. Hold it like that. It will work. And this is the 40 times magnification, 1.30 NA, oil immersion. Plan fluoro means it is corrected for the operation for the sample. I mean yeah, and then it is infinitely corrected, and 0.17 millimeter thickness of the cover slip should be used, and the working distance is 0.2 millimeter. Okay. And I will find the hole here. And which one you use, which port you use, is there shouldn't be any what's that, the word here. There's a PF 40, but you probably don't want it. You just use this non-labeled port. Tightly, make it tighter, and then do this, and then you will put the sample on the linear stage over there like that, right? For example, right? And then put the oil immersion. Put the oil immersion. This is to hold the sample tight. If you need it, you'll probably use it depending on the purpose. So everything is depending on the purpose. There's no right answer. It depends on you, right? You can put some sample and then hold it, right? In this way, and then adjust the height of the linear motorized stage using the code, using the computer, through the computer. So it is basically connected to the computer and software. So make sure the objective lens is not contact to contact any very sharp or keep it clean as possible. So it should be immersed with immersion oil over there. So that should be used. The drop of it should be used, like for example, on the sample cover slip or to contact the objective lens. So drop of it should be used. Okay. So I guess there will be some repetition, some repeat every time I make this video. I'm sorry for any inconvenience of it. And the light source for this one, same, the laser is same. The laser will comes up to over there when you turn the laser on. So the objective lens will be implemented in a slightly different way. As you can see, it is inverted, right? So for example, every time we do the single molecule spectroscopy, we use this 100 magnification and 1.5 NA microscope. So as you can see, it's very clean. So that should be clean as possible every time you use it, and clean it with the close for all this objective lens cleaner. And actually we are out of it. This is the last fit. And so for example, you clean it with this paper in this way, like this way, right? And you can use ethanol to make it clean if there is some dirt, but not much of it. I mean, some drop of ethanol should be enough. And try not to close it too tight. This should be enough. So when you carry it, you need to be very careful because it's very expensive, right? So I will show you how to implement. I'm not sure how to handle this. Let's see. So push this back and put the microscope here, right? And make it tight, but not too tight, right? Should be very naturally. And put the oil, a drop of oil on it, and then put the sample on that. When you put the sample on it, I recommend to use this metal ring so that the sample doesn't move much as possible, right? So put the oil drop on it and then put the sample on it, and then you will see the sample. If you want to see how the sample are, how the laser focus has been made through the eyepiece. Here is another knob over there. So when you push in, the light will go this way, your eyes. When you push it out, the light will go through bottom to this optics. from this hole to the bottom, the meter and beam splitter and the detector in 2 ways. That's why this beam splitter is placed as 45 degree. It is hard to take those in one video, but if you see in your eyes, you will figure out what I meant. And those electronics are connected to, it is called MCS. So those electronics are called MCS and single photon detector, and it's 16-bit acquisition. And this computer will be used for both piezo stages and electronic detector, both of them in this computer. And the light source for the from here, I mean from here, that is the light source for the power of the light source from here, the white light. The white light will go here. You see the light has been come here, right? So this is how you use the light source. And I will make another video for the make sure you turn this off, right? I will make another video for the emission line adjustment for this one.